Hey guys, we're going to be charging the Ecoflow using capacitors. These are Maxwell 130 farads, 56 volt capacitor. I have two of them connected in parallel, so they're both connected positive to positive, negative to negative, giving me two banks of 48 volts. Okay, 56 volts, that's 48 volt full charged. It's actually like 57.6. So we're going to be using 48 volts to charge the Ecoflow. So if you remember before, when I used the wind turbine, I used batteries. I'm going to try using capacitors. These are, if you've never seen these are Maxwell technology. It has 130 farads, two banks. So we're going to see, I'm going to full charge them and see how much charge I can get to the Ecoflow. We're right at 92%. Okay, so it's almost full charge, but it should be enough to get this test. I don't know how much power we're going to get from this. So we're going to measure it and see how much we get from this. I also have a AC charger that's going to allow me to charge these up. So I'm going to charge it up. We're just going to see how much watts we get on the input side. Then we'll run a full all the way to zero. One thing with capacitors, unlike a battery, they can charge and discharge thousands of times with no problem. I also have it connected to the wind turbine. This cord right here is going to the wind turbine. It's connected also. I set the charge controller to 48 volts, but there's no wind today, so I'm going to be using the AC charger to full charge. Let's see where we're at right now. Okay, it's right about 11.83. And even at 11.83 volts, it will still allow it to charge the Ecoflow. So using the wind turbine with capacitors, I think that's going to be 10 times better than using the battery bank, because the batteries, once they go below half, they just struggle. This thing has no limits. It will charge at any voltage. You know, the Ecoflow will charge all the way down to 11 volts and then will stop. So this thing right here is perfect for that. 11 volts. I'm going to plug it into the DC charger just so I show you guys that it will cut off at 11 volts. So we're going to come back here. I'm going to connect the DC. Okay, guys, so I have this right here. Remember, the DC charger on the Ecoflows have a cigarette lighter plug. So I have a cigarette lighter plug here, and it's going to one negative, one positive on the capacitor. We're right at 11.6. So I want to show you guys that once it gets to 11 volts, it will stop. Let's plug this in. Okay, I plugged it in. You hear the click? There you go. So the capacitor, no problem for it. We'll still give it. See right here? Now it dropped down to 10. It's going down fast. It's also going down over here, getting ready to shut off. I want to see exactly. It said 11. Down to 9.3, still charging. Still pulling 63 watts. There you go. Okay, so it's 8.5, guys. So here's the exact number. The Ecoflow stopped charging your battery at 8.5. That's horrible. It should be exactly, at least, I would like to see it stop charging at 12 volts. so it doesn't kill your battery. I mean, it went all the way down to 8.6 before it shut off. So they need to check that. You guys need to make sure it shuts off earlier than that low. It's gonna do a lot of damage to someone's battery, especially if you plug this into your car and you walk away. You won't be able to start your car back at 8.5 volts. All right, we're gonna charge it back up and see if it shuts off again. I'll get it to 14 volts and see if it shuts off. All right, so I'm gonna plug in the charger. All right, charger plugged in. That's the charger. We're going 186 watts, 19.2 amps. I'll disconnect this so it doesn't start charging again. Well, actually, let me let that stay connected. And I want to see when it starts charging again. So that's the voltage right here, 11. Here you go. Yep, start charging right about 12.4. Okay, remember that's the battery voltage, the capacitor voltage, I should say. I want to disconnect it. Okay, so I disconnected the charger. Let it run down again. Remember, this will go all the way up to 56 volts, all right? My AC charger will only go up to 54.4. Okay, let's see at what voltage it shuts off again. I have it at 8 amps on the app. Let's see what voltage it shuts off. I would really like for it to shut off right about 12 volts. That way, if you have this connected to your car, and let's say you're out in the park and it's charging in your car, you shut the engine off, it should shut off. Okay, here we have 11.7 still charging. Remember, guys, we're using capacitors, so it's going to run down pretty fast. But you can see, even at 11 volts, it's still be able to pull high amps. 10.6. I really would like for this to shut off earlier. If this was a battery, it would be done. Okay. 9.4. Come on, guys. You guys said it would shut off at 11 volts. That's 9.4. 9.1. Still charging. All right. So it's 8.6. It shuts off at 8.6. Okay. So that needs to be updated. Okay. So now we got confirmed that the Ecoflow stopped charging on DC at 8.6 volts. So if you're charging this in your car, do not leave it unattended. It will drain your battery all the way down. Okay, let's do the next test. Let's go ahead and get this all the way up to 48 volts. And so that's right about 54.4. And see how many amps we can pull on DC. All right, let's plug in the AC and charge this thing up to full charge. AC charger is plugged in. I disconnected the DC side, so it's not charging, okay? If you guys wondering what charger this is, Let me show you a closer look. IOTA Engineering DLS 54.4. See, we're up to been 4 minutes and 22 volts and counting. We're going to go up to 54.4. We got 413 watts going in. All right, let's keep charging. 750 watts. Okay, if you see this flashing, it's not flashing, it's just the LED, okay? It's at 54.4, 54.5, 100% charge. Okay, so they're full charge. Now we're gonna do DC, all right? I'm gonna disconnect the AC charger, okay? So it's at 54.3. Let's go ahead and plug this in and see how long these two capacitors will hold on charging. Let's do DC first. So we're gonna see how much can you pull from these capacitors at 48 volt. We'll switch to the solar second. We'll do the DC plugs first. Okay, so it's full charge. I think it's full charge right here. 54.5. That's the highest this charger will go. 54.5. So let's go ahead and connect the DC and see what we get. All right, let's connect this. All right, 48 volts. Let's see how many watts we pull from the to the Ecoflow at 48 volts. I have it set to 8 amps. If you guys, so we're getting right about 450, 500. It's dropping fast. Remember, I have no power coming in. So it settled at 415. If I had the windmill going, charging this at the same time, it would keep up. Or any source coming in, but I have no source coming in. So we can get right at 410. It says it will be full charge in 51 minutes at that rate. So if you use 48 volts, guys, you can go up to 400 watts. See, I'm still well over 48 volts. Let's go ahead and recharge it to full and plug the solar connectors and see what we can get, okay? So I'll stop it there. Okay, so I went ahead and disconnect the DC, charge it back up to 54.4, and we're gonna connect the solar. Remember, I have this this wire right here. It's connected to the battery as well. Well, it's connected to the capacitors. So we're gonna get solar from this. We're gonna use this as a solar cable. So remember, this is for the solar. Plug it right here. Okay. Once it's full charge, I'll connect the solar cables and we'll see how much we can get from this. So I'm going to connect it to this MC4 connectors. I have it connected right here. Since it switches to solar somehow and it pulls more amps. I'll show you the sign that comes up when it goes to solar. Okay, we're full charge. All right, guys, 54.2. Let's go ahead and connect the MC4 connectors. Red to red and black to black. go. All right, you see this right here? How it comes up? That little solar panel sign? There you go. Finally stopped doing that. 780. And it's going down fast. So it doubled the rate. So just by using the solar cables, you doubled your rate. Now it's getting almost 765 watts. And it's going down pretty fast. The capacitors, because there's no power coming in. So yes, you guys are right. If you use the solar cable, okay, it's rechecking this thing, recalibrating. 46 volts, pulling 600. So these capacitors, they have a lot of power stored in them to be able to pull 640 watts. Reset my timer. About 42.7 and going down. Unlike a battery, you have no set power. It will pull that same power all the way down. The capacitor, the Ecoflow, will stop and recalibrate as it goes. See, it's also dropping the wattage to keep up with the incoming power. And 36.4. $35.7. Okay guys, I'm gonna switch back to the DC cable for solar panel. It works perfect because solar panel has the consistent power coming in. So let's switch the cables. Okay, we're down to 35.5. I switched the cable back to DC. I'm gonna plug it in. I went ahead and plugged it in the socket. Okay. Now you can see, since I plugged the DC cable in, that little solar light will not come on. Solar panel cable you get in 30 minutes. Switch back to DC, jump back up to an hour. Well, we went from 92 to almost 94% just on this thing. And we still have 33.4 volts to go. If I'm using this with the solar panel, if I'm using this with the wind turbine, I think DC is the way to go. The solar cables just pull way too many watts. It's just too fast. You want to go slow and steady. I would even drop this down to 4 amps just to keep up. Okay, guys, we're up to 95%. We're pulling 220 watts, and we're at 28.4 volts. Okay, guys, we just got to 24 volts, so that'll be like a 24-volt battery now. Pulling 181 watts. Going down. Maxwell capacitors charging the Ecoflow. Okay, guys, as you can see, we're right at 13.5. That would be like a full volt. That would be a full charged 12-volt battery. And you can see it's pulling right about where it should be if this was a 12-volt system. Yep, 12.9. This would be a full charge battery. So 96, 95. It's calibrating as it's going down. As the power goes down, the input voltage goes down too. If you times this by 8, you'll see it's keeping right up with the 8 amps. 90. So this is where I would like to see the Ecoflow shut off charging. Right at about 11.8, 12 volts, I would like to see it shut off. That way, if you have this connected to your truck battery and it's not running, it would shut down. I'm going to see if I can connect a controller that will shut it down before it kills the battery. Because if you run your battery this low, you're in a lot of trouble. You can't restart that truck if you forget this thing plugged in your truck. Right about 76, 75, 10 volts. Remember, it shuts off right at 8.5. Still charging. 68. This is where it stops. Right about 8.5, it will shut off. Right there. 8.6 is where the shut off is on the Ecoflow. All right, guys, so thanks for watching this video, guys. I just wanted to show that you can use capacitors to charge the Ecoflow Delta Pro. Okay, real quick test, just having fun with it, seeing every other way I can use this. Just trying to figure out different things we can do with our Ecoflow. I know most of you techie guys want to know stuff like this. So we're just going to use the capacitors. As you can see, the wind just started going now. Now this thing is charging back up. Right when we're done with the test, that's when the wind starts. So there you go. The wind turbine is charging it back up. Now the wind is coming. It's not turning real fast, but just that little wind is enough to charge back the capacitor. Okay, guys, thanks for watching my video. Just a quick test using capacitors to charge the Ecoflow. If you like this video, go ahead and give me a thumbs up. Guys, leave a comment. Let me know what you think. If you have any ideas you want me to try, put them in the comment section. I really appreciate that. Just hearing from you guys. Okay, thanks for watching my channel. Have a nice day. Bye.